All right, pen. All right. First up, all this here is just declarations. I'm declaring that an LED exists, and I'm assigning it to a pin number. Now, this int word here, this int, that is a special type of thing. It's a data type. It's what's called a data type. Does anybody remember what a int is? An int is not a string, it is an integer. It's a whole number, exactly. They are whole numbers or counting numbers, 0, 1, 2, 3, or -1, -2, -2, or -3. All right? Now you have to college computers are stupid. They don't know the difference between a whole number and a decimal unless you specifically tell them. So that is where the int comes in. We'll get into floats or doubles and all that stuff a little bit later. But the main thing is that int is a whole number, and the value that the highest number that an int can have is dependent on the computer in which you're using, which I know it gets a little bit confusing, but for Arduinos, I think it's like 32,000 is the highest it can be. I'm not quite positive about that, but it's in that ballpark. And when in your standard computers, it's about like 1.3 million, I think is the highest. But again, that's all dependent on the operating system. And it goes to the negative too. So negative 1.3 million to positive 1.3 million. Now, these words here, these I don't know why, but these words here, this one, y'all are smarter than me, but these words here confused me for the longest time. I thought I had to say there was int and LED for the computer to know what an LED was. No, that's not the case. It doesn't know that it is an LED. All right, I can make that anything I want it to be. As far as this computer is going to be concerned, or as far as we got this code set up, this is the only thing it is sending voltage out. Now, the LED can be any name I want it to be. You can see here I went from LED 1, 2, 3, 4, 5, and I just skipped over to Illuminati. And that is perfectly acceptable as long as I keep using Illuminati all the way through this code. That everything is still exactly the same. It does not matter that that's called Illuminati. It's going to be a send of voltage out. Now the void setup. What's the significance of a void setup? What does it do? And yeah, that's the main question I want answered. What is a void setup? That's the next part. Exactly. Good job, Mr. Dennis. So the void setup in the Arduino program, that was doing one thing that it already says it does. So it's setting up certain libraries, certain outputs. In this case, here we're designating everything output. Some people saw in the last code, if you did not do this, your light was a little bit dimmer. It still ran, but it was a little bit dimmer. So it wasn't specifically allowing certain currents to flow through. You'll get more of an intuition of what setup is as we go along. But for right now, it only runs once, and it's used to designate certain things as far as pin numbers and libraries. The void loop runs continuous, right? The void loop runs forever and ever and ever and ever and ever. As long as it has, as long as the Arduino has power, the void loop will run. Now, notice I said as long as the Arduino has power, the void loop will run. It does not have to be hooked up to a computer in order to run, as hopefully we'll learn later on in class or later on. Now here in the void loop, you can see that this is getting kind of redonkulous. If I was to keep going, if I had 10 LEDs, it would be, 3 more lines or 4 more lines of code or some ridiculous amount. And programmers are what? Everybody got that one, yeah. Programmers are lazy. And actually, honestly, like all of this stuff here, I copied this one, I pasted it, then I copied two more, and I pasted it, then I copied all four, and then I pasted it again because I wasn't going to type out all that stuff. So there is a simpler and more elegant way of doing this, and that's what we're going to kind of go over tonight. Now, if you do not already have your computer or your Arduino hooked up to your computer and your Arduino open, let's go ahead and do that. And Zach, how you coming on this circuit, man? Do I need to help you out, or you get it? All right. Well, I'm not gonna. I'll keep it kind of slow for right now. Um, how far are you along, Zach? Okay. All right. All right. So let's see what else is there. So if you have Arduino open, which you should, we're going to go ahead and open up a brand new sketch. Now here, this time around, there's going to be you can do a little bit of copy and pasting, but I do want you to start typing stuff out instead of just using examples. It does really help sink some stuff in. So, and here's the first thing we're going to do. The first thing I want you to do is we're going to get the basic code structure set up. This hopefully will help you keep track of things. So I'm going to type the void setup. I'm going to put a open bracket, open brace. Can y'all see that? Do I need to increase this font? Yeah, I'm going to increase this font a little bit. Let's go 18. Yep. Hang on, I'm getting to the template. I do want y'all to type it out instead of actually using the bare minimum, because it does help you to understand once you start typing it out. So the void setup here, and I'm going to put an enter open bracket, and to give myself some space, and I'm going to close the bracket out. And to come down here, I'm going to type in my void loop with the open parentheses. Now, again, these are parentheses. These are braces. All right, those are the braces. Two different things. Parentheses, braces. And then I'm going to go ahead and put all my braces for my void loop, which is just an open and a close. So this is the basic SketchUp. This is where we start. Now, doing it this way here, right, is here we can actually reduce pretty much all of this here, all of this, and all of this down to like almost, 2 lines of code. All right, that's what we're going to do next. And where is it? There it is. All right. And to do that, and I want you to notice why or how we can do this. Let me see. Let me try to phrase this a little bit better than I did last class. So right here, I'm going to focus in right here. So you notice here is what I'm doing is I'm doing the exact same thing, but I'm doing it in a matter of iterations here. So this is LED 1, this is 0, 1, 2, 3, 4, 5, 6, 7. But everything else is exactly the same. So, and in SketchUp, in Scratch, I mentioned I tried to drill something into your head. Use a certain particular loop. Y'all remember what that was? That does something at a certain time or certain iterations.
Muted.
What's up, Tyson?
I didn't do anything.
Oh, your hand was up. I was just curious. All right. How you coming, Zach?
I got the LEDs and the resistors set up now.
All right.
I'm just gonna get the wires.
Okay, cool. Remember, the positive is the long leg. Positive is the long leg.
Okay.
Resistor is the short leg.
Alright, I got that.
Alright. So here we're going to use what's called the for loop. Again, notice here I'm just doing the exact same thing over and over again, but I'm doing it a certain number of iterations. And so if you use a for loop, that actually does make this process a whole lot simpler. All right, and what a for loop is, the basic structure of it, is I'm going to go ahead and type out everything about a for loop without any information. So for loop, I put 2 open parentheses, and then I'm going to put an open bracket, give myself some space, and a closing bracket. So I got, this is an empty for loop, and I write for, it's called a for loop because it has the word for in it. And that has a open parentheses, closed parentheses, and then a open bracket, and then a closed bracket, or open brace and closed brace. 5 volt and ground. All right, let me come back to that one. Yeah, so this is your ground. You don't need the 5 volt. That's completely irrelevant. Again, for every class and every circuit, I'm going to assume that the ground is there. I will make special mention of when the 5 volt is needed. Yeah, we're not going to need that. I don't think we're going to need that too much. I think we're going to need it for the next class, but I'm not positive. All right, so here's the empty structure for a for loop. And I'm going to try to come inside this parentheses. So a for loop does something a certain amount of iterations. And by iterations, I mean a certain number of times. So in order for it to do it a certain number of times, you have to specify how many times you want it to do it. All right? Or how many times you want to do it. And that's what the parentheses is for. All right? So just a few times we're going to put information inside of parentheses. All right? First up, I'm going to call it an int. I'm going to initialize a variable for the for loop to count. All right? And I'm going to be very clever. I'm going to call it counter. All right? Int counter equals 0, semicolon. And I'm going to change this here in a minute, but int counter equals, so I'm initializing a variable that's an int of a counter. And I could call this Jack Sparrow if I wanted to. The name doesn't matter. Int counter equals 0. So I give it a initializer. I'm giving it a variable to count. And then I tell it how much I want it to count to. How high do I want it to count? In this case, we don't have any pins higher than 10. So I'm going to go counter less than 10. All right, because you should only have up to pin 9 plugged in. All right. So again, this is the initializer. This is how high I want it to count. And now I give it the information of how I want it to count. All right. So in this case, I'm just going to do, Well, I'm going to do counter plus plus. Now, what counter plus plus does, that's just saying, I'm just saying count plus 1. So every time this loop iterates, every time this loop goes over, it's going to increment the variable of counter, which I've set to 0, by 1, and it's going to go all the way up till 9, not 10, because 10 is equal to 10. It's going to go less than 10. I'm getting, good catch, Wade. I'm going to explain that one here in a minute. All right. So here I'm saying int counter equals 0. Counter is less than 10, so it's going to go from 0 to 9. And it's going to, every time this loop iterates, it's going to do it counter plus plus, or plus 1. Now, as Mr. Wade, good. Hey, good. Y'all are catching it. I talked to him. As of right now, the answer is yes, Josh, and I'll tell everybody at the end of the class what your question was. As of right now, that might change. So everybody's already starting to notice that we don't have, we're starting at 0, so 0, 1, 2, 3, 4, 5, 6, 7. But what did I tell you? I've told y'all specifically never to plug anything to 1 or 0 unless I specifically tell you to, right? And in this case, this is not one of those times. So where does the count start? But it starts at 2. So I'm going to go from 2 up to 9. So simple fix. Boom, 2, done. Now I'm going to erase my stuff there, so I think it's getting in the way. All right, so now I need to tell it what I want it to do here. And I'm going to go ahead and put this in here. What I want it to do. That's what goes here, inside this for loop. Because I am the master of the for loop. All right. So in here, inside these two braces, you gotta keep track of these braces. This is going to be the majority of the error I'm going to find in your codes is the braces. All right. So inside those braces, I tell what I want the for loop to do because I am the master of the for loop. All right. So let's see. What do I want it to do? Zach, how you coming on the circuit, man? I didn't know I could switch slides. I'm kind of flying by the seat of my pants right now. Okay, awesome. What do I want it to do? What do I want it to do? Where's the code? There you go. So I'm going to put these two codes up side by side from each other. Now, well, what do I want it to do? Well, I want it to do this, 8 times, right? Because it's 2 less than 10, 8, yeah, simple arithmetic. I might switch that around. I can't remember right now. So here I'm just going to say pin mode, open parentheses, counter, comma, output, and then close it up like that. So now I have taken all of these lines of codes here, and I have simplified it into literally 2 lines of code. All right. Now this for loop, this idea of a for loop, because it's less than 10, Jacob, it won't get up to 10. It's going to stop at 9. So Jacob asked, shouldn't 10 be 9? Well, if I did it like this, yes, it should be 9 because that's greater than or equal to. But because I do it like this, it won't go past 9 because I stopped it at 10. Right? This is just a simple. Remember the alligator eats the bigger one or whatever it was, or the finger points to the little one. So 2 is less than 10 to the 10 to the 10. Okay, Josh. Just remind me after class. All right. So here I set everything to an output. So that part of the code is done. Oops. What time do I have? All right. So here, now let's look at this structure here. This just looks all kinds of confusing. I wonder if I could simplify this down. Shouldn't we? All right, hang on. I got three different questions here. Should we shift the wires in our Arduino boards from? Oh, yeah. Well, if you have it at 3 to 10, you can just change this to 3, and then this to 11. If your wires are set up that are plugged in from 3 to 10, just switch these numbers versus switching the wires. It'll make your life a whole lot easier. So just change this to 3, and then change this to 11. That U looks more like a finger than... yeah. With this mouse I have a gaming mouse, so there's actually a PID control system underneath it. So, which is why I'm actually a better drawer than that, somewhat. Not that much better, but a little bit. Now, hopefully we'll get to what PID means. All right. So let's look here. Let's look at how we're going to do this. First up, what am I doing? All right, I'm doing this once, I'm doing this again, I'm doing this, etc., 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 all the way down. I'm just saying digital write high, then I'm delaying it, and then I'm doing stuff low. So let's just turn all that stuff into a for loop. And I'm going to minimize this. I'm going to bring the slide up here. Now, one thing I didn't do, I did want to point this out. Where's the... Oh, not that. What's that blink? There it is. Blink. One thing I did not do is in the code we're working on now, I did not do all this initializing stuff. More likely, I will continue to do that just because when you start manipulating variables, if without initializing them, things get fluid, then you get gremlins in your system, and then all kinds of fun stuff happens. But this is going to be one of the few instances where I'm not initializing things up top. All right. But this counts as initialization. All right. I know it's kind of confusing. I'm kind of like talking in circles a little bit, but yeah, it's just I don't know how else to explain that concept. All right. Anyway, let's move on. 4, this is one of those times, do as I say, not as I do type things. All right, so here I'm going to go ahead and just declare a for loop. And in this case, I am going to copy all this because I'm lazy. I'm going to paste it right in there. Done. And here, what do I want it to do? I want it to go, what, digital write, right? Let's see. Blah, blah, blah. For int counter 2 less than 10. Don't do it like that. I think I jumped too far ahead. No, that works. Actually, I don't want y'all to do it like that yet. I want y'all to do it like this. Alright. So this is inside the void loop. Everything here, they're missing a parentheses right there. And that should be a bracket. And same as that one. Okay, there it is. Hopefully my slides that I make are a whole lot better than that. All right. So here, I'll give you both examples of it. So go ahead and yes, write this out. And once you get it written out, you should be able to go ahead and upload it. And all your lights should flash on and then flash off. Like every single light flashes on and then every single light flashes off. I double, triple check all your braces. Remember that. And I'm going to change that up after y'all get all that done. So here. What? Take this. Copy. Paste. Change that to below. And I'm done. Alright, raise your hands when you have all that code typed out. I'm already done, so y'all should be almost done too. Right, once you have it typed out, go ahead and try to upload it to your Arduino and see if all your lights are going to turn on and all that fun stuff. Make sure mine's right too. Yep, they should all blink at the same time. Now, I know some of you are still typing. So as Dennis is noticing that they're all blinking at the same time. Now I want to caution you that's an optical illusion. They're actually not blinking at the same time. It just happens so fast that you don't notice it. And I'll prove that here in a minute. So let me ask y'all this while y'all are still working here. Do y'all like it seeing the code more like this or more like this where you actually see me typing it out? Y'all like seeing it here on the Arduino or here in the slides? Both? Okay. Few people prefer slides, few people prefer typing. All right. I'll try to do both. Miss Celsi, go ahead and put your hand up. So I'll know that you have yours working. Again, once you upload the code, raise your hand up and so I'll know. And all your lights should blink on, and then they all should blink off. Now, if all of them except one or something like that is blinking, check your circuitry. Mr. Zach said, now Mom and I won't have to buy Christmas lights. You know what? Every freaking Christmas, I get somebody wanting to do that, wanting me to make a string of LEDs that blink in some form of way. I've never done it yet because I'm just, no. Well, one, they want me to do it for free, and that ain't happening. Yes, they should keep blinking over and over and over again. That would be cool. Let me see if you do that, Celsi. That would be awesome if you were able to actually do that. You might have to learn how to solder. You should work in a plant that makes LED Christmas lights. How about own a plant that makes LED Christmas lights? That sounds a lot better. All right, if you're having problems, let me know what your problems are. You can think it's code or hardware. If you get a compiling error, let me know. I can usually help you out quickly with that. If you have a circuitry error, I can't help you out too much with that. Well, I can, but it takes a little while. I don't think Mr. Jacob is saying that a whole tree would take a long time to do in code. I don't think it will. Here we did 8 LEDs and 1, 2, 3, 4, 6 lines of code. I did 8 LEDs. There's no reason why I can't make this 1,000. There's no reason why I can't do that. And it'll still work. Josh says, you can do it. Doing it the other way would take a while, yes. Josh, you got yours working, man? Raise your hand up so I know so I can move on. If you have a compiling error, let me know. If you have a circuit error, also let me know, and I'll try to help you out, diagnose what it is. Mr. Roseman and Zach, I'm not seeing hands up. Good question, Zach, and yes, there is. I don't think we'll get to it tonight, but yes. Zach asks if there's a way to make the lights fade on and off. There's several different techniques, and we'll go over the main one in class here. I might even try to do it. I might try to do it in this class. We'll see. Zach, are yours working? I got error. Boy, loop, error expected. Okay, you're missing a curly bracket somewhere, Jacob. Or Roseman, Mr. Roseman. So, looks like error expected. Looks like you're missing this one here at the end. So, the way I check for curly brackets, I can usually just scan through it. But when I couldn't do that, I would go, okay, I got an open one here. I got 2 opens. I got 1 closed, so I got 2 minus 1, so I have 1 open. I have 1 open. I have 1 closed, and then the other closed. So you just do a little, just kind of follow it through here. I have, where is the closing one that corresponds to this? That's way down here. The opening one for this is the closing one of this. Done. Jake, if you want to copy and paste your code, I'll look at it that way too. That might save some time. You can just copy the whole code, paste it into the chat box, and I should be able to get it. Or Control A, copy, Control C, or Control A, select all, Control C, copy, Control V, paste. All right. While I'm working with that, code works but no lights. Do you have your, does your mic work? Let's find out. Can you talk, Mr. Jake? Did your mic work? I can never remember. Nope. Okay. No light. No mic. All right. So if you have absolutely no lights, the first thing I'm thinking is that your ground is misplaced. So let's go back up here to the circuit real quick. Everybody else, I want y'all to figure out how to get the lights to flash on and off one at a time. Go ahead and take a few minutes to just try to do that while I'm helping out Mr. Roseman. All right, so Mr. Roseman, if you have no lights, the first thing I'm going to ask is about this ground here. Do you have that hooked up? This one right here. Yay or nay, Mr. Roseman? Tyson, how goes the Eagle Scout project? You finished your Eagle Scout. Oh, congratulations, dude. Thought you were still working on your. Oh, I got another student working on this project. That is awesome, man. How old are you? 15. You already finished. Wow, dude, that's killer, man. I am quite impressed. You beat me by 3 years. Of course, once you started driving, Scouts gets a lot harder. Because freedom. But dude, congratulations. I'm quite impressed, man. All right, Mr. Roseman, I need some information, man. Why are your lights not working? Help me help you. All right, is your ground hooked up? That's my first question. Right here. Okay. Do all of these wires here correspond to the long leg of the LED? So all of these wires here should be in the long leg. The positive is the long leg. Okay, you say your connection is bad, but which connection? Are you going to get your GED, Mr. Wade? Or are you going to do the early college program? I'd say go for it. Okay, cool. All right. So are your lights flashing now then? Awesome. Okay, cool. We can move on. Sweet. All right. So we come back to the code. All right. So what did I say do? I said, oh yeah. So y'all noticed that the lights were flashing on and off at the same time. I said that was an optical illusion, that you're not really seeing that. All right, and here I'm going to prove it real quick. Not that one. I got too many Arduino programs. This one. All right. So here, if we actually just add, and actually let's change one other thing here. And this you won't find on the slide. I just make it, I think it makes our life a little bit easier. So here I'm going to create another variable. I'm going to go int here, and I'm sticking with the same concept of, who am I looking for? Who's the author of The Time Machine? Help me out here. The original Time Machine. Somebody here knows it. H.G. Wells. Thank you. I'm going to call this variable HG equals 1,000. So this is a time variable. All right, and I'm going to plug in HG here and HG here. So this is the exact same concept. This is the exact same code. I'm just, if I change this number here, right? Remember 1,000 is 1 second, so it's staying flashing for a second, off for a second. I'm going to create another variable here. I'm going to call this one int, what's another time traveling reference? I used Doctor Who last time. I used flux capacitor last time. Give me another time traveling reference. Stargate? No. I'm probably gonna... Quantum Leap. I like that. Back to the Future. Quantum Leap. I like that. You know, technically, Quantum Leap is just a small... Yeah, I'm not using Back to the Future, so I need another... Marty. There we go. Marty McFly. So let me call this one Marty. Equals 250. Enter. All right. Cool. Here, I'm going to come here. Now I'm inside. I'm going to go inside both for loops, and I'm going to put Marty in there. All right, and then you'll be able to see that the lights shut on and off at a set individually, not all at once. It's just that it's happening so fast that you can't even notice it. So here I'm going to put Marty, delay Marty, and here you can use whatever reference variable you want there. I was just trying to really hammer in the fact that the variables don't matter. Now, as far as coding etiquette, your variables have to make sense. All right, so that's why I'm using time traveling references, because these are all values of time. All right, now if I load this code up, what should happen is the code should flash on and off at different rates. Or actually, wait, you see them all turn on, and you'll see them all turn off. And of course, if you increase or if you change this number around, you'll get a little bit different. Whoa, what happened here? Somebody did something. Who is this? I am not going to look through that code. What is this code? What did you do, Jacob? Int counter equals 6. Why did you do one for... Oh, okay, yeah, that does work. Okay, I see what you did, Mr. Murray. Wow, you did it the hard way. So, can I put your code up, Jake? All right. I don't know if I can even get all of it. Here, you put this. So, this is how Mr. Jake decided to do it. He wrote a whole bunch of for loops, which does work. But which way do you like better? Who's the more lazy? Who's the laziest person here? All right. All right. So now this is just one way of doing it here. Now Gabe and Zach have figured out how to fix the Knight Rider effect that I was trying to get earlier in the other class. All right, how much time do we got? All right. So now they're going up and down at a set rate. Now they turn the same way they turn on is the same way they turn off right now. So here, next I'm going to try to do something a little bit different. I'm going to try to create what I call the Knight Rider effect, where the lights kind of bounce back and forth from each other. All right. So without getting too complicated, right? How do y'all think I'm going to? How could I do that? Give me an idea. Great, flash your hands. Let's get more people talking than typing stuff out. So if I want the lights to go from, so they start at 2, they go all the way up to 9, and then when they shut off, they start at 2, they go all the way up to 9. Now what I want to happen is I want it to go from 2 to 9, and then the lights go from 9 to 2. How often can you push the... Wade, I'm not understanding your question. Push the lights on or off? Oh, delay it. I'm actually not sure about that. LEDs have a long lifespan, so I'm not quite sure actually of that one. What do you think, Marty? Or not Marty?
You know how it says counter 3, counter less than 11? You could switch and say 11 and then counter less than
Exactly.
3.
That works. Exactly. That's exactly how we're going to do it. So here, first thing I'm going to do is I'm going to decrease Marty a little bit. I'm going to make him 50 just because. All right. So they come up, turns on, and then I'm going to shift it back down, and I already have a code set up for it, so I'm just going to use that one. I think this is it. Yeah. Load this thing up, make sure it's right. Okay. So I did something a little bit differently. My bad. Now I'll come back here and do it. So here, they come up, and then I want them to shut off. So I'm actually going to add in this here. I want to take this digital right. How much time I got? And I just copy this low here. I'm going to paste it in. So it's going to turn everything off or everything on, and then it's going to turn everything off. And then I'm going to do very similar. I am going to copy all this here. Copy. Paste. So let me undo what I did so I can go back over it. All right. I'm going to copy this, paste it in there. Done. Almost done. I'm going to copy all of this here, and the Control-C copy, and I'm highlighting all of this, and now I'm just pasting it. Now I have like shortcuts on my mouse that allow me to do that really quickly, but it's the same thing as hitting Control-C and Control-V. Now the way to change this up is here we're saying +1, so now we're going to turn it on, turn it off, or delay it, and then turn it off. So this one is simple. It's going 10 here, like Miss Celsi said, going less than 2 or greater than 2. I always get those mixed up. And now since I'm starting at 10 and I want to go to 2, I use what's called the decrement operator. Hit play, and hopefully I got that right. Let's see. Yep. Who else sent me? Is this you again, Dennis, or is this? Oh, Mr. Murray. Or wait, or am I looking at the same way? I'm so confused right now. Let me figure this out. So now, what should be happening is